Hey guys, so I'm adding a little bit here kind of after I originally recorded the rest of the video. I realized I didn't explain this idea of cumulative frequency and relative frequency like super in-depth in the original video, and especially related to how we make the kind of graphs that I talked about, so I thought I'd add in a little bit here. So we're going to start with Javon's basketball scores, the ones that we were looking for in percentiles. And what we're going to do here is fundamentally what we were doing when we found percentiles. We're asking ourselves for cumulative frequency, if I'm at a given value, we're asking how many values in the data set are this value or less. And with cumulative relative frequency, we're doing the same question, but now we're asking what percentage of the values in the data set are this value or less. If we only have a few data points like we do here, we can just do it by counting. Well, how many values of 0 or less do we have? We have 1. How many are 6 or less? That's 2. 8, that would be 3, 4. And then we run into our first problem here. Well, there's 2 11s. So would this be like 5 and 6? No, because we can't really prioritize one 11 over the other. So if we take the way we phrase this seriously and we ask how many values in this data set are less than or equal to 11, 11 or less, the answer is 6 because we count both the 11s. So then now, if we go for 13, that'll be 7, 8. We have another double, so both of these will be 10. Then we get 11. We get another double, 13 and 13. Now we get like 4 more here of 18. So if we get like 13, 14, 15, 16, 17. So there are now going to be 17 values of 18 or less. 18 for 19. Then 19, and now we're at the full 20. So right, by the time we've made it up to this game of 24 points, well, if we're looking at these 20 games were 24 or less, right, the whole distribution. But now you might be asking yourself, well, hey, Miss A, I thought you always told us that like 20 is the bare minimum for what you want in a data set. You know, what happens if we've got 100 numbers or 200 numbers or 1,000 numbers? Like, do you want me to go through and count up all of these like this? Absolutely not. We do not live in the Stone Age. We have computers. We can do this like sensible people. So what I'm going to do is here is I'm going to insert another row below, and we're going to find these cumulative frequencies a little more directly using Google Sheets. So now this isn't going to be like the simplest formula we've ever used. So here we want to do a count. If you just start typing count, you see, oh wow, there's like a bunch of counting functions in here. And what we're going to want to do here is, right, we can't quite do a simple count because of those double values, right? Like where 11 and 11, they both have to take on the same count. So we're going to do count if. We're going to tell it to count up things, but we're going to give it like a condition to check for. So first thing we do is we specify the data range that we're counting within. So this is our distribution. And then we're going to give it a condition. And so now let's say, right, if I was just using a regular number, like if I wanted to ask like how many values in here are 17 or less, what I could do here is we always put our conditions in quotation marks, and then it'll look something like this. So right, this means count up everything that's less than 17. So there are 11, which isn't what we got because that didn't include the 17s. We can add an equal sign here to make it less than or equal to 17, and now it updates. So now though, right, we don't just want to look at one value at a time. We want to be able to point at each value. So how do we do that here? So we can't just have the number here. What we'll do is we'll just have that sign, the less than or equal to, use the ampersand, the and symbol, and then reference the cell. So basically now this translates to count everything in this range less than or equal to the value in B1. And we get 1. Now we can autofill to go across, but we need to kind of fix our formula a little bit. We always want the data range to be the same. We want it to go from B1 to U1. So we're going to need to add our dollar signs to kind of fix these in place when we autofill. So now these will not change as we go, but the B1 will. We want this to go from B1 to C1 to D1 to E1 to F1 and all the way down the line. So we want these to be able to change. Okay, so now that we've got our dollar signs in there, I press enter and we can autofill going down the row. Bam. Wonderful, right? Exactly the same numbers, but this time we got Google Sheets to do the work instead of us. Much less likelihood of getting an error, much more useful when you have large stacks of information. So once we have cumulative frequency, remember frequency is very easy to turn into relative frequency. Same thing goes for cumulative. It's the same idea. You take a given frequency value and you divide it by the total number. So we can do this again using a formula. So we can take the cumulative frequency value and then divide by the number. So say I could go with 20, I could just type it in. But again, what if we have a bunch of data and I don't know the exact number? We can use another one of these counting functions, the simple count. Just count up all the numbers in this range. And I can say, all right, count up all the numbers in row 1, right, by doing 1:1. Or I can be more specific, you know, say like B1 to the end of row 1. Or if I know what the end is, I can say B1 to U1. Just depends on whatever it is that you know. I will just do it this simple way, right? So we're just going to do it for all of row 1. So 1:1, bam. And then now we can autofill going all the way down. And now what have we done? We've taken these frequencies and just turned them into percentages. Percentages of the whole data set. So now we're asking, like we can say here very clearly, okay, 30% of values in the distribution were 11 or less. And again, right, this is in those terms when we're speaking in percentages, that's what a percentile is. So we could say here, okay, this is 85%. So we could say 18, the value 18 is at the 85th percentile. A 19-point game would be at the 90th percentile, and so on. So really, the percentiles are just a way of expressing cumulative relative frequency. Cumulative relative frequency is sort of the fundamental thing there. So now how do we make a graph of this? Because really it's the graphs that we tend to like with this. So here's what we do. I want to select the original data, and then I want to pick the cumulative relative frequency row, but not those ones in between. So what I'll do is I will hold down the control key, or if you're using a Mac, the command key, and I'll select the other row. So now that we have those two selected and no other rows, we can go to Insert, Chart. And you know, at first it gives us a column chart. I don't know why the Google AI wants that, but what we want is more like a line graph. So beautiful, there we go. So we have cumulative relative frequency here on the y-axis and points on the x-axis. Let me make that clear. Points per game. Okay. And now we can think about, well, how do we read this? So we can go either way. We can either ask ourselves, okay, what value is at this percentile? So say what value would be at the 25th percentile? What value would be at the 50th percentile? What value would be at the 75th percentile? And wait, now that I think about it, these are just quartiles, aren't they? Right? The lowest 25% of the data, the bottom 50% of the data, right? These line up with different quartiles. And that can kind of give us this idea. We can, in a way, read it off of here. We realize, okay, the first quartile goes all the way up to 10. The next quartile goes up to 15. The quartile after that goes not even that far, up to about maybe like 18 or 17. And then the final quartile would be like 17 and up. So we can directly look at it that way. If we want to get a little bit more precision here when reading this, because, what about anything in between? What if I want to know what value is at the 65th percentile for some reason? Then what we can do is we can go here to the chart editor. Under Customize, we can go to grid lines and ticks. And so let's start with the vertical axis. Let's add some minor spacing. And, since these are all divisible by 5, why don't we basically count up by, 5 percentages? So what we can do here is under step for our major spacing, right, we could change this to 0.05. And now that adds a bunch of grid lines. Another way to do it would be to leave this blank and use minor spacing types. So if we're going by 5%, we should expect 4 minor spaces before we hit the next major one. So right, 5, 10, 15, 20, and then we'll get a major grid line at 25. So that's 4 minor grid lines. And so, depending on how you like your chart to look, you can pick either one. So this way now we can read it a little more clearly. So say the 10th percentile would be 5. 65th percentile, right, if we go 50, 55, 60, 65, we have it here. And that's going to correspond to, well, this one's kind of hard, so why don't we do something similar with our horizontal axis? Here, again, we're counting by 5, so maybe let's have our minor spacing be 4 minor spacing things, right? 1, 2, 3, 4, and then 5 is the major grid line. So it's always kind of like the number of things that you think you want minus 1. And so again, we have a little more detail now. So if we go to the 65th percentile, we go across, we go down. Okay, that's exactly 17. Or we can go the other way. We can go by asking, okay, if you scored 13%, or if Javon scored 13 points, what percentile would that put him at? So that would be, we can kind of go up here and go over, and this will be right 25, 30, 35th percentile. So this is how we use cumulative relative frequency tables. Again, using those count and count if functions, we can kind of automate the whole thing and do it fairly easily. So now back to our original programming.